Good morning already. I fell asleep for a second there, and I think I forgot to start the video when the timer ended. But I'm okay now. So hope you all had a good 4th of July weekend. We didn't have class on Friday because it was observed day, the day that UNLV closes in observance of the 4th of July, since it was on a Saturday. So sorry I didn't let you know on Thursday's video, but I did let you know on Canvas at least. So hopefully nobody actually put an alarm to actually see the lecture when there was nothing. So cool. All right then. So today we are going to be covering a little broad range of topics that will hopefully strengthen the things that you can do in C++. And since I will talk about arrays, I am gonna do a little practicing on arrays, since you guys seem to be having a hard time with the grid on the assignment 10. So maybe that'll help out a little bit. So yeah, and string streams, class construction, function overloading, each of those individually will not take more than maybe 10-20 minutes. So I can spend a considerable of time in arrays, and then if we need more stuff to talk about, we can talk about pointers or memory. So yeah, that's the plan. Okay, so let me start with okay, let me draw a picture, why not? So far, I mean, we haven't technically done this, but I do think that you already suspect that it's possible to do. But let me show it to you. So you have C in arrays and vectors, which allow you to keep sort of a table of data, and that could be a multi-column, multi-array table if it's a 2D. If it's one column, multiple rows, that means it's a single one-dimensional array. But if it is multiple rows and multiple columns, it's a 2D array, and technically it can keep going further. So if instead of being a 2D table, it could be a 3D table. There's a depth, then it's a 3D array. And so you can store as much data as you want. The cool thing about vectors, you can push things in, or with arrays, you got to decide in the beginning, and so on. Cool. I talked to you about structs. Structs are like the bucket, and in the bucket you can keep a bunch of individual variables, right? So you can declare inside of your struct variables, and those variables can be of different types, which means that while this is homogeneous, this is heterogeneous. I don't know how do you pronounce that, but what it means is that this has to be one type, and the other one has to be can be multiple types, right? Multiple types, one type. Okay, so I guess the question should be, cool, I can keep individual values, and of course you can also keep the operations that you do on those things, right? We said you can throw in functions inside of your structs or classes, but can you, and should you, I suppose you could ask yourself whether you should or not, can you also put in this bucket, which is getting kind of big, an array? Can I throw it in there? And the answer is yes, you can. You can have arrays inside of your buckets. So you're not limited to individual variables. And that's the one thing I haven't quite shown you. And so in this case, you could have multiple arrays, each of a different variable type. And that way you have all these variety of data that is stored inside of one bucket and self-contained. You can also, I told you already last time, that you can have arrays of structs, right? So we even did that. That's the Twitter assignment. You know, you can have arrays of these buckets. And within the buckets, you can have arrays of something else. Well, guess what? You can also have in your bucket, so this is, you know, you could have just data and an array in the bucket. You can also have an array of those structs, so arrays of buckets. And then go a little bit Inception style. And if we make our bucket even bigger, that was like a XXL bucket here, family size or whatever. You can have structs inside of structs, so you can have buckets inside of buckets. If I can, gonna have to make it a little bit smaller so it fits in there. Right there. It's like a matryoshka of buckets, and those little buckets have their own things inside, which could be arrays, could be variables, or even other tiny little buckets. And the word tiny is subjective here, because really the array inside, or the bucket inside, the struct inside, could be just as big, if not bigger, in terms of content. Now in theory, I suppose, because the outer one contains the smaller one, it's technically bigger, but still, you know what I mean. So if I make an array of these, you know, I can do something like that. But the question is, first of all, how do you deal with arrays inside of structs? That's the topic. It's going to be quite trivial. You just deal it the same way you would outside. And also the other question should be, when you have something of this sort of nature, where you have a bucket inside a bucket, a struct inside a struct, how do you access the members inside of it? And it turns out that it's also quite straightforward. But, you know, I'll show you. Basically, if we give names to our buckets, we'll call this one bucket A, and then we'll call this one bucket B. And then let's say this is variable X, and this is array R. And then this is variable Y, and this is array V. If you're trying to access X, you know, you use a member access operator, which is a dot, and then you put a variable name, X. Turns out when you're trying to access an array, you do basically the same thing. You just a dot, and then you put the name of the array. And obviously you want to access a specific index of it, so, you know, like 2 or something. Cool. All right. Now finally, let's try to access something inside of B. To access something inside of B, what you're going to do, let me put some space so you can see it better. What you're going to do when you access something in B is you're going to put A dot, and then B, and then dot again, and now you have access to anything inside of B. So if you want to do the Y, you can put a Y. If you want to do the V there, you can also do A dot B dot V, and then there's an array, so maybe you access, I don't know, the 4th element. Okay? Now, A and V are the identifiers of a specific instance of the bucket, right? So I'm saying this is called bucket A, and this is called bucket B. But the type of the bucket could be called, I don't know, Home Depot bucket, and then they want, say, Lowe's bucket, right? That's the type name, or the struct name, or the class name, whatever name you want to call it. However, when you create an instance of that, you gotta give it an identifier, and that's going to be basically your A and B. So it's the same thing as saying an integer versus like X, right? You don't say integer dot something. You would say the type name. You would say the instance name dot something. Okay, if integers were classes. So yeah, that's pretty much all there's to it. But I'll show you some code. Yeah. So let's go ahead now and actually go into code. And how about we show a 2D grid, since that's kind of like the assignment, and we can do that as a struct. So let's code. All right. All right, so let's just make sure that everything compiles fine. So let's compile and run. Okay, so now we got a clean slate program. It's running. Everything is good. So I don't think we need any includes right now. So I'll just put the space like that. So let's first make a struct, and let's call it game grid. Or to avoid making lines long, let's just call it grid. And also, I'm gonna make it uppercase. Yeah. Okay. So actually, oh no, I got a better name for this. World. Yeah, world is better. Okay, so this is gonna be our world. It's where you store everything about a little game. And I'm also gonna show you incursives today. Yeah, I forgot to put that in there. I want to show you incursives. Makes things easier for a couple of things. So let's actually include that. I don't think you need the .h. I'm gonna comment it out though, because first I want to show you the struct and like we'll switch it over to incursives. But okay, inside of here, our world, what are we gonna have? Well, we are gonna have a round count. And I'm actually going to use the word class because it looks fancier, but I'm going to basically make it public. So for all intents and purposes, I could have said struct. So my round count is going to basically just be a variable that keeps the number of rounds that have passed. I don't know if I'm going to get to using that, but I'll just throw it in, just to see that the bucket has a bunch of things in it other than the array. But now let's actually do the cool thing, which is the array. Now in my case, my array is just going to be an array of characters. So we're going to call that the grid, and we're going to give it some dimensions. Let's go ahead and make those some defines so that we can easily change them. And we're going to call that grid X and then grid Y. And we're going to make those 10 by 10. If you go any bigger, you'll see it on such a small terminal, I think. Well, no, that's a lie. Probably go bigger than that, but actually even go smaller for this, for example. Okay. So here's the thing about the terminal, though. And I think I said this at some point, but if not, then here you go. Imagine this is the terminal. The terminal window, okay? And you gotta compute these coordinates based on this terminal window and the way it prints. It prints from top to bottom, left to right, the way we write. So you gotta decide what is the point 0, 0. Now, normally when you're thinking of a math problem, you would think of either having it a plot like this, where the center 0, 0 is right in the middle. If you have all 4 quadrants, like positive x's, positive y's, and then you have the bottom quadrant, which is like negative x's, negative y's with positive x's. You could also have like the left quadrants, which, top and bottom, which could be negative x's, but you have positive y, or negative x's and negative y's. So you don't have that here, and so you wanna go even simpler. You just want to go with something that starts from 0. So then in math, and this is gonna be hand waving. I can just show you with drawings here. In math, so what I was saying is, in a plot you have this, and then 0, 0 is there. So if you do like -5, 2, that would be about maybe here. And then if you did 20, 20 for some reason, I don't know, 20, 20, that's like way up here. This may not be the scale, warning. If you want to do like, if you want to do 5, -5, then that would be, I don't know, again, definitely not the scale, but that would be about here. And so you don't need this when you're doing the game. You can just have this kind of graph, just one quadrant, which is this quadrant. However, when you're printing stuff, And when you're writing in real life, again, you write like this. From the top left corner, this way, and then this way, right? So you write an entire line, and then you go to the next line, and then you write again, and then you go to the next line, and so on. So what we end up doing is we gotta flip our system here. We gotta take our graph that we would normally consider that works this way. We gotta flip it that way. Okay? And so now our X and Y's are like that. Now, yeah, you could flip them. You could do like the X still be the horizontal axis, but at least for the way that we're handling it, we gotta commit to one way or the other. You know, it's kind of like row major versus column major. And so when I say something is 8 by 8.5 grid X and Y, I'm going to be considering that I have it like this, with X being vertical and Y being horizontal, and my 0, 0 being on the top corner, which means that if I was to plot in this graph like 1, 3, that would actually be 1 here. Let me actually put lines to this to make this a little bit more to scale. 1, 3 would actually be here, whereas 3, 4 would be 1, 2, 3, 1, 2, 3, 4. There. What about 6, 1? That would be 1, 2, 3, 4, 5, 6, 1. Be there. Okay. And so if I'm trying to, for example, render a square inside of my grid, then what I have to do is I got to compute the 4 points that I want to do it. So if I want to compute something that is like, for example, a square right here, whereas everything else I want to have print out with some specific character, and then this I want with a different character, what I need to compute I need to compute the center and then compute the 4 corners. And then that way I can use math to see anything within this range, render as something. So that's kind of what we're going to try and do. So remember, here we go, that up here, this corner is 0, 0. Okay. And I guess just so it's not square, we can make this 10. We'll commit with that one. Okay. So when we're creating our grid here, we got to choose. And like I said, if I choose it this way, then I just got to remember that this is the order that I'm choosing. The other way could work around just the same way. It doesn't matter, because when you're printing it, it's when you decide how you print, which dimension represents what. But you just have to be consistent. Don't like magically flip them around and things break. So, okay, we got our grid. What else do we want to keep in here? I don't know. I think what could be useful. I don't know. We will add as we go. How about that? Let's create a function. That would be actually useful. Let's call it print grid. That's a void function, and it doesn't require any parameters because we're using a class variable, which is grid, which controls the size, so we don't need to worry. You could also, if you're a good programmer, you wouldn't be using the defines. You could probably declare the local variables here, like grid X and grid Y inside of the class. But I'm just gonna leave it outside because easy way to update them, without creating a function that would do it. So okay, okay. So let's go ahead and declare that function. But I'm gonna do it outside the class. I'm gonna try to keep it compressed. Otherwise, we're gonna run out of space here on the screen pretty quickly here. I think we still will anyways, but yeah. All right. So void print grid is just gonna print out the grid. Oh, I know what we want also here. We want to do something called setGrid that initializes the grid. But for that, yeah, that's going to segue into constructors. But we'll create the function first. But before setting the grid, I think it would be useful to be able to actually print it first. And so, how do you print this 2D grid? Well, you can just use 2 for loops. If you do 1 for loop, you would print out just 1 row of it, or 1 column potentially. But because you want to print out a 2D thing, you gotta go all rows and all columns, and that basically makes it a 2D loop. If it was a cube, so it's like a 3D array, you would need 3 for loops. You could also use while loops or anything else, but for loops is the most intuitive. In fact, I wouldn't even use a range for loop. I would just use a normal for loop because that's just kind of what I'm used to. So here's the first sort of sketchy thing that you got to make sure you don't screw up, and that's basically the counters on each of the loops. You know, you want to make sure that you're going through both the X and the Y columns, but use different variable names for each of your counters here. And then when you're printing out here, which to print out, so here you're just printing a single, in fact, here, let's do baby steps. Let's just print out 1 row at a time. For now, just 1 row. Because Y is going to be a row. Remember that. This is the Y-axis, and which kind of goes backwards from normal plotting, where that would be the X-axis. So this is what I'm trying to warn you is, don't screw up by putting an X here and a Y there, and then you're printing a column instead of a row when you intended to do the other thing. That's what I wanted to get to. Okay, so which is which? Again, look at this declaration. X is going to be first. So Y is over here. So this is the one that we want to put. In fact, if you want better named variables, you could call this Y. Makes a little more sense to actually have this Y, because then here it's a Y. For now, we're going to just print 1 column, which we'll define. We're going to print the first, row. The first row. So I'm going to put a 0 there. Eventually, I'm going to put the second for loop, but let's do baby steps. Okay. The thing is, I need to also set it. Otherwise, actually, I'm curious. Let's see what print out. Maybe it'll print out a bunch of zeros. Who knows? We'll see. This might be actually good. I'm curious to see what is there. But first, we got to actually declare a instance of this class. So how do we do that? Again, you just do world, and then what we call it, we'll call it game. That's not a really good name. Maybe make that uppercase, world, and then call this level 1. How about that? Level 1. Yeah, the first level of the game, right? Okay. Which means we really should have called that level. Yeah, I like the level now more better. This is giving me flashbacks to the CSGO assignment from 302 actually. Okay. So now it makes more sense to call it level 1. Okay. So we just created an instance of it, and now that we have created an instance, we can access variables and functions from it. So we can use a remember access operator, and then if we wanna set the round count to something, you know, we could do round count get 5. If we want to set the grid, we could do something like this. We can totally do this. We can totally do grid and then 0, 0, or 0 square bracket 0, and set that to something. So we're going to set that just randomly to an asterisk, and that's it. And now I'm curious to see what the rest of the row is, because it should be random stuff, but it might be initialized by the compiler to 0. We'll see. So how do I do that? How do I see it? Well, I created this little nice function called print grid, which is not appearing here. Why is it not appearing? Oh, I see why. I never declared it here because I forgot to write the class name. So there we go. Why isn't color changing? I probably have a typo in the code somewhere. Ah, yes. No, it's not this actually. Although I really should have commented this one, but it wasn't that. Here. Probably that. Anyways, let's just compile it. It'll tell me where. If I think I have a typo somewhere. It will tell me where. Line 29. Ah, here's the typo. Semicolon missing. There we go. Now it's color coded. So that's kind of a sign that it should be okay. One more error though. Line 38. Oh, I never finished writing that line. So I'm going to call it print grid, which now will actually show up in my autocomplete. Right, that could work actually, putting it here, but don't do that. It's bad coding. Cool, it compiles. Therefore, it must work, right? Not really, but you know, we'll see. So there's a bunch of garbage there. I mean, we do have our asterisk, So that's the one that we set manually. But then you get all these question marks. That means that these are invalid, in invalid range probably of characters are stored in there. What if I wanted to see the number that's in there, just to see? Let's actually let's do that real fast. Also, we should end line here. But how do we do that? Let's cast this to an integer so that it prints the number that is stored there, and then we can better find out in the ASCII table what that would be. So the asterisk is 42, I'm gonna guess. Let me pop open the ASCII table. $42. Yep, you can see right there, the 42 is the asterisk. And then from there, we got a 0. I don't know, probably just a single 0, which is null. Then you got a bunch of 0, 0, 0. Then you got like a -1, which is definitely not something in the ASCII table, which is probably why you're getting all those question marks. The nulls is probably just ignoring. And then you got a 1 in there as well. Now that's assuming that each of those are numbers, but I think a better thing to do to confirm that is to put space between them. Both will work, by the way. Oh, accident. Yeah, that's much better. So basically we got zeros and -1s, and we got a 1. So as you can see, this is just random garbage. But you know, it's trying its best to interpret that random garbage as valid characters. That's why when we switch back to just being a car without doing the static cast, let's get rid of the parentheses. The one you think you have to have those there. We get that weird garbage. And I think maybe different times you run it, you might get different things. In this case, no, it's giving us the same thing, but it could, because again, it's undefined behavior. It's just whatever was left in memory there. Okay, so let's go ahead and actually initialize our grid to something, and we're gonna not initialize it to blanks because that's hard to keep track of and debug initially. We can later on switch it back to blanks, but for now, let's actually initialize it to something more meaningful, such as asterisk. Actually, why not? Yeah, let's just go with the asterisk here. So we'll I guess the first one now we'll change it to something else, an @ maybe. But how do we initialize our row? Because again, we're just working with a single row right now. Well, you still need a for loop, but instead of couting, you want to assign something to this position. That's convenient. I can see that. You want to assign the individual character. But again, we're not using space. We are going to use asterisk. Oh, come on, compile first and run. And you can see that it's still the same garbage. Why? Because I didn't call the function to initialize it, right? I need to actually do this. Level 1 dot set grid. Oh, you know what would be cool? Yeah, let's actually add a parameter here called car, and then what could be a good meaningful name for this? Setting the grid to car. Okay, whatever. Just C. And set it to C. So that way, our function can set the grid to any character that we actually pass as a parameter. So then we can actually pass here the asterisk. But that's cool because like I can change this very easily. You know, I can call this at any time and change what it's rendering like in the middle of the program. So there you go. But like if I want to call in the middle of the program, like set grid to something else, I can very easily switch it over. And that actually might be useful for our purposes. So yeah, that's actually, now I made that into a happy function. It'll actually stay there forever. So in that case, let's go ahead and move it out. We're going to call that void level set grid RC, like that. Get rid of that and get rid of this. Perfect. Just make sure I didn't break it. We're good. Okay. So next, let's go ahead and expand our program, because right now we're just printing a row, but we want a 2D array. So let's go ahead and add a second layer here by adding rows, or just, yeah, rows. Because we have, I guess we have one row, multiple columns. Now we want multiple rows, multiple columns, right? So that's basically what I had here, which is just the outer for loop. And again, it's going to be the same thing for setting them printing, so you can literally copy paste. The only difference being, of course, that this variable has to be different. So we're going to call that x because that's actually more meaningful. And then here, you no longer just set it to one individual thing like 0. You can just set it to x's value. And then basically do the same thing for this one. So I should have changed it before I copied and pasted. Like that. And so now if we run it again, okay, where did I paste an x, a row xi here? There we go. One more error. Oh, I lost a plus apparently. By the way, just so you can see that you don't have to do plus plus, you can do plus plus x. It works the same way in this specific scenario. There you go. 2D grid, easy. Took us like 10 minutes, whatever. Mostly talking. So, yep. Okay. So, from here, what do we want to do next? Oh, let's talk about constructors. Yeah. So, here's the thing. I have to call set grid, right? If I don't call set grid, we're going to get some weird garbage printed out. Oh, voila. That's actually kind of cool looking. Not going to lie. Run it again, and it's a little bit different. See that? This little hat symbol became an unknown symbol, and this LN is like an I bracket. So as you can see, whereas before we were kind of getting lucky and getting the same random garbage, this time we actually got different random garbage pretty much immediately when I run it again. So I guess the more memory you use, the higher the chance that you're not getting the same spot in memory assigned every single time. So yeah. So anyways, it's kind of annoying as a developer if every time you're creating an object, you have to initialize it with a different function. Would it be nice if when you create an object, things get initialized to something that you preset? And the answer is yes. And I showed you actually how to do part of that. I told you that you can always do something like equals 0 here. And as long as it's C++ 11, because if you try to compile like this, it gives you a warning. It doesn't give you an error, but technically that's because you should be doing this. Oh, what did I do that uppercase there? Then you don't get a warning, right? So that's one way to initialize variables. But how do you initialize this grid? You know, you want to do this? No, you don't. That's horrifying. And this basically tells you that that's a really bad idea to do. No, I didn't talk about this though. In theory, oh yeah, I'm surprised I didn't mention this when I was talking about arrays. I should show you that real fast. But let's take a pause for a second from doing this constructor stuff and go to main. Here's a little cool sort of bonus thing about arrays. If I make a little 1D array, and this will work for multiple array dimensions, but let's just start with one dimension. Let's say you make an array of 5, and you know, you could then initialize each of them by saying R0 gets 4 and so on. And then if you want to print out the entire array, you can put this in a little for loop. Actually, here, let's just arrange for loop to review that. For x, for int x in R cout x. And then, yeah, like that. So there's garbage in all but the first one. So if I run this again, you know, let's add some line feeds so you can separate this. Oh, thanks for this reminder. So I'll go over what I just wrote in a second. It's because I was looking at this. I gotta look here because this is what's actually streaming, so I can keep track. So I guess I'll look here. But then this way you can actually see my face. I'll have to flip that. So, okay. We need spaces. Okay, so we got the 4 because we initialized that, and the rest is garbage, right? And maybe if we run it again, yeah, we get different stuff. Cool. Okay, so I forgot to show you this on arrays, and it's because it's kind of unused, but it's kind of useful. And that is, there is a little sort of shorthand to initialize arrays where you don't have to go in a loop like this. There is this syntax when you're making an array of this type, which is a static array. You can put the curly brackets. And then you can sort of put each member and what you want to initialize it to. And as long as the sizes match, you're good. So there's 4 and 5. Like that. And if you do that, everything got initialized to 0. Of course, I then immediately change the first one to 4, which is why you see a 4 there. But yeah, this works. But I don't have to stick to 0. I can do some fancy things here. And that's because this is really a constant. It's like a really big constant that you're trying to set up, and that's what this is really happening here. But you can still modify it, so I guess it's not quite much of a constant. So, yeah, this is. I actually don't know what this is called, but it's just another way that you can initialize arrays that you know have to have this data in the beginning, and it's pretty cool. So yeah, I forgot to show you that. So my bad. Well, it's not really used like I said, which is why I didn't remember it. But now I did, so yeah. Because I was actually thinking of using it for a second. There are limitations to this. I don't believe that you can put a variable here. Like, you can't do something like this, as far as I know. Let's start throwing in the round count. That's a variable, technically. Level 1 round count. As far as I know, that doesn't work, but I might, be surprised. No, it did work. So you can actually throw variables in there like that. Okay, that's cool. Let me triple check. I actually want to make a variable now. Int a gets 10. Let's change this 2 to a 10 then. See if that works. Oh yeah, it worked. I stand corrected on that. That's pretty cool. If you want to do this with a 2D array, that gets a little bit weird. You just flatten it and just keep going here. So 3, 4, 5. Sure. Let's see. Oh, but then this thing, it gets confused here. So here we need to do another for loop for int y and x. Alright, so now this is how you would print a 2D array using range for loops. If I remember my range for loops correctly, which I don't think I do, because I got an error. Oh, that should be good. Each of those is an array. I probably messed this part up. Let me see what the error is. Invalid conversion from pointer. Oh, it thinks of it as a pointer. Okay. Alright. Oh, maybe this thing is trying to tell me that I'm not smart. I have to do something like this. Fails to determine the size. I guess you have to do dynamic arrays to get away with doing a range for loop. Let's just go with what it tells me to do. Begin was not the correct. Yeah. So this won't work. And I is equal to 0. I is less than 5. I plus plus. And y is equal to 0. Y is less than 2. Y plus plus. And then C out R, don't get this wrong. So the outer one is the I, and the inner one is the Y. And then let's put a line feed between them. Okay, so let's see if this is good. Why is this? See, it does not name a type. I must have made an error which is flowing into other errors. Yeah, there's like an extra curly bracket somewhere, so let me see. I equals 0, I is less than 5, I plus plus, y is equal to 0, y is less than 2, y plus plus, C out. Where is my error? Line 59. I'm missing something somewhere. Here, let me just comment out this piece of code. We'll come back to it. Let's just see if the top thing will work. Okay, so that works. So the error is inside the for loop. So for int I equals to 0, I is less than 5, I plus plus. For int y equals to 0, y is less than 2, y plus plus. C out. I don't know why that's giving me an error, actually. C out does not name a type. I'm using namespaces, but if I do that, it's still giving me the same error. Oh, it's not this one, it's this one. The error must be in this line. I must just not be seeing it. C out R I Y. It's called R. And then this. I don't know. I don't need these curly brackets, and yet I'm still gonna put them now because now I'm really not sure as to why this is doing this. Is there somewhere an extra bracket? No, there's not. Not that I see one. So, okay, let's just comment these lines out for a second. So here you have a live action of trying to debug something. Oh, I see it now. I'm dumb. Okay, it's here. I'm missing a bracket. That was the problem. Yeah. This bracket was missing right here, so I don't need these brackets. This ones that I have here. I should put them, but I don't need them. But yeah, so this bracket here, because this bracket was missing, let me tell you what was happening. So this was the error I was getting, right? I was missing a bracket here. And so this for loop was considering this piece of code to be inside the for loop. So that was okay. It was thinking that this was actually outside of this for loop. And then this curly bracket was matching the one from the beginning of main. And so that was closing main. So main ended. And then you had this random code that was not part of main, outside of main. And so it was thinking, it was like, what could it be? It could be a global variable. It could be a function declaration or definition. And so it doesn't name a type. It's basically saying normally when you have something in the global scope, if it's a variable or if it's a function that you're declaring as a global variable, global function, you do something like int x, right? And that's a global variable at this point because it's outside. Because this curly bracket was thinking, oh, it's part of that. And so it was basically saying this must be a global variable declaration. And the global variable declaration would be like a type and the variable name. And that would be okay to the compiler. However, cout is not a type. And so that's basically what the error was saying. Cout does not name a type. What are you trying to declare here? And if it was a function, it would be something like void foo. If it's a void function, or if it's a value returning function, it would be like int foo. Again, void and int are types. So the compiler is expecting the first word that it sees to be a type, and this is not. And so as you can see, this error cascaded from something completely unrelated. And that's why in this case, the error was not relevant to us. But at the same time, it kind of was, if I remember, that why would it think it's a type? Oh, it's because it thinks it's a variable declaration. And then the second error is sort of what hinted me to something being wrong with curly brackets, but not early enough where I figured out immediately, because it says expected declaration before that. Again, if it sees a curly bracket, but there's no leading curly bracket, so again, in the messed up world of the compiler at this time, because it assumed that this is a function declaration, you know, per se, or a variable declaration. Either way, you know, you'd expect that if you have something like int foo and you see a closing curly bracket, it's because there was an opening one like that. And so that's why it was saying expected something before a closing curly bracket. So weird error for what we actually had. And it was completely unrelated, because the real problem was that our curly brackets were not matching, because we forgot to put that curly bracket there, which would then make this a closing curly bracket to the for loop. This would be part of main, and then this closes main, and that would, of course, solve the problem. So there you go. That's an example where the compiler was essentially useless, but not really. It's just more of my lack of detecting that error meant that there was something that was kind of closed out of the function. So yeah, anyways, I'm glad we figured it out. Now, the reason why I was doing this in the first place was because I was trying to show you that you can do this interesting method of initializing an array for more than just a one-dimensional array. What you do is you just sort of write things in a flat manner, and if you see it the way that they print it, it's basically taking each of these as rows. So it's filling each row as it goes. It doesn't fill by column, it fills by rows. So even though it's what I guess is a 2 by 5, or 5, I don't know what we call this, 5 by 2 or 2 by 5. It doesn't matter. The point is it's 2 columns, 5 rows. But the way that it fills it up is it fills each row all the way, and then to the next row and to the next row. It doesn't fill all column 1 and then all column 2. It fills all rows first as it goes. Okay, so that's kind of what I wanted to get to. So when you get to initializing multi-dimensional arrays in this method, you got to make sure that you remember that, because if you thought that this was gonna fill all the columns, all column 1 first and then all column 2, like vertically, then you were wrong. Now, if you want to do that, if you wanted to print the array like sideways to sort of hide yourself from doing that instead of fixing it the right way, all you gotta do is you could have just flipped the for loops here, and that would actually do it. So do something like that, and then after you do that, don't do the same mistake that I did with the curly bracket. Make sure you have this curly bracket here. And then I flipped the thing on the side just by flipping the for loops. So I guess this is a useful thing to know. If your array prints in the wrong sort of print sideways, just flip the for loop so you can flip it up, right? Or vice versa. So anyways, but again, this initializes by row, not by column. Okay? So there you go. That's what is that called? What is that? There has to be a name for that. Initializing arrays with curly brackets. Curly braces. Are they called braces? I always call them brackets. I'm sorry if they're called braces. I'm used to calling them brackets. No, they are brackets. So Google just lied to me with autocomplete for a second there. I think it's called, if Stack Overflow is correct, it's called Aggregate Initialization. Yeah, it seems to be the case. Is this C++? I wonder if that works. So, anyways, this is called Aggregate Initialization. Okay? So, I didn't know that actually. So now I do. But I'll probably forget it. Maybe I won't. We'll find out in a couple years. So what I'm looking at here is they're saying that, I don't know if this is C++, it might be, this works in like Python or something, but I don't know if it works in C++. They're saying that you can actually separate this with internal curly braces. if it makes you like make it sort of easier on the eyes. Like that. Let's see if it compiles. Nah, it didn't compile. So I guess they're just talking about a different language here. Stack Overflow is wrong. They lie. But yeah, what is true though is the name, because it seems to be true. I mean, most people keep saying it's that, so it must be that. So like Aggregate, because it does them all at once. Maybe. I personally know Aggregates as something related to 202, which has to do with actually having objects instead of objects. It's kind of what I was showing you with the struct instead of struct, and you call it aggregation. So I don't know why they're using that terminology here, but it might be right. So you can think of that for now until you take 202 and you find out the other definition of aggregation. You're like, why? So yeah. Anyways. A little sidetrack there, but useful because it is one feature, and that way if you ever run into code that you see that, you're like, what the heck are they doing? Are they trying to declare some weird format of a function or something? No, they're just initializing an array in a weird and very just weird way. So yeah, okay, so look at that, because I'm going to get rid of it from our game because it's unrelated, but it's on the video, so you can go back. For now though, it is going away. Shoot. Okay, so back to our game. I was going to show you how to do constructors so that they can initialize the grid automatically, right? And that's cool because I hate having to initialize objects after I create them. I want that to be automated. I'm lazy, etc., etc. Okay, those can be the reasons why. So we have this thing called constructor. And a class constructor, it's basically a procedure or function that runs when the object is created for the first time. There's also something called Destructor, which is a procedure or function that runs when the object goes out of scope, which is more related to memory allocation stuff, so that's a 202 thing. But for now, I am going to show you the constructor. I said I would not show it because it's 202, but I'm going to show it. So, okay. How do you create this magical constructor? All you gotta do, and this is a little bit weird from the syntax that you're used to, is you write the class name, you put parentheses, and then you put the body of the function. And you're like, huh? There's no type here? You just literally just spiel for like 10 minutes about types and how the compiler caught this type issue and not. Yes, but there are exceptions to every rule, and this is one of them. And that is the constructor of a class or a struct, because this works the same for struct or class. I can literally change this to struct at any time today as I'm running this code, and it'll work the same way because I have public here. So yes, for class or struct, the constructor is a function that runs when you create the object, and because it is just a little function that runs things, it is neither valid returning nor void. It is some weird Twilight Zone middle ground. You just accept as part of life. It doesn't make sense for it to be valid returning. Well, actually, no, I could see it being a thing. So, I don't know. I don't question it. Smart people created this, and they thought it was a good idea to not do this. So, we must embrace it. So, what can we do in this? What is a good thing to do? Well, this is cool and all, but this is C++ 11. And if you don't want to use C++ 11, this won't work, or at least you get that warning. So you can technically just initialize something here, and then you avoid this. And now we no longer are going to get the warning if we compile in not 11. And that's because of this specific compiler in Ubuntu is compiling with 98 or something. So that's why I do get those warnings. Whereas Sally, you won't, because it's default 11. But you could probably do that and make it force you to give the warning. So yeah. Anyways, so that's one usage of it, but that's not the real usage. The real power is you can do a bunch of other initializations and other fancy things. When you learn about memory allocation, this is where you do it if you had actually a dynamic array or just pointers in general. But in our case, this is the perfect spot to initialize the array. So I can just copy and paste my set grid code inside of my constructor, and then, you know, pick something to initialize it with. And so now, if I didn't make any mistakes, missing semicolons or whatever, it initializes it automatically. And I can make more of these objects, and I don't ever need to call set grid. So then set grid is useless? That's what I thought when I first wrote it, but then as I was saying, it might actually be useful if in the middle of the program we want to change the grid to something else. So it's still useful. But what I'm saying is, this is less prone to errors. You don't need to initialize. You just create the object, and you know that not only do you have this little bucket, but it has been cleaned out and organized and everything for you. It's ready to, it's actually really ready to go now. So constructors are very powerful. And by default, C++, this is some for your information thing. By default, C++ has a default constructor. So far, until right now, all the structs that I've been making or classes had no constructor in them. But C++ still adds one in. It's just you don't see it happen. The compiler basically adds it in, you could say. What's in it is just empty. And technically there's also a destructor, but it's also empty. If you want to see when it runs, we can actually add a cout statement saying constructing. And you would see that every time that you create an object. So here, let's make another object. Even though we don't do anything to it, let's just make it. So like level 2. Second level of our game. Constructing, and then we print out the array, and then you get another one, which is constructing, which is actually when you made the second one. So you can see that that is called automatically when you create the object. Similarly, if we had a destructor, which again I'm not really going to talk about, but I still want to just show you how you make one. You just write the same thing, level, but then this time you put a tilde at the front. And now you're at the body of it. So for now, we're just going to say destructing, because it's a destructor. That's useful for when you need to do something when before the object goes out of scope, which is when you never use it again. And typically, if you're working with memory, you deallocate memory so you don't have memory leaks. So that's the real purpose of it. There's something known as the rule of 3 as well, if you want to Google that. But as you can see, I get 2 destructing calls here. Because when main ends, these 2 objects, level 1 and level 2, go out of scope, which means they'll never be used again. So the destructor runs automatically. Right now, by default, there's nothing on it. Although I did go ahead and modify that and actually added the word cout destructing to there so you could see it. But if there was any dynamic allocation in here, I would throw it in there to deallocate memory and save memory leaks. So yes, we'll leave it there. Why not? One more thing about the constructor is you can have parameters to it. So I could have something that says car seat. And in that case, I can do the same thing that I was doing kind of with set grid, where I can basically just pass in when I create the object. I can actually put parentheses here and pass in parameters to the constructor like that. And so now if I run my program, it's actually going to initialize it with that, because this parameter in the constructor is used as what I'm setting the grid to. So now oh well, because I did that, this is a good point. So this would have worked, but the thing is I got an error. And why did I get an error? Because I require, now that I've added something to my constructor here, a parameter, I'm saying you have to give a parameter when you're creating an object, because I need to know what this is so I can initialize it according to your rules. So that's kind of forcing me to give it a parameter now. I'll tell you how to avoid that in a second. But now you can see that we got this, and in fact here, let me call print on the second level. Because I passed in a different character for that one, so I want to show you that it worked. There you go, see? The first one is with C's and the second one is with X. Worked out good. So, what if I don't feel like sometimes passing in? Sometimes I want to have like a default parameter per se, or a default value for a parameter. Can I do that? Yes, you can. And you can actually do that with regular functions. So this is a good time to actually talk about default parameters. Whenever you have a parameter in a function, so if you have something like void foo, you know, you could have something like int x, right? And then you know, you can say cout x. And assuming this is passed by value in this case, that's okay. We can call foo here. We'll call it all the way to the bottom, right before the program ends. And look this way so you can see what's happening. I'm worried that I'm going to go off the screen. I can say foo and then int. The little thing that I was explaining for the grid, that it was part of the documentation for foo. That's why you see it there. But hey, that's pretty cool. If it was real documentation, it would show it there. So yeah, 5. Okay, and so if we run this, semicolon. I think there's more errors though, because I just see more things. But yeah, line 64. Request for member print grid on level 2, which is a non-class type. Oh yeah, I still haven't actually fixed that part. So here, for now, let's just add in that. So anyways, okay, so you can see the 5 there. By the way, the 5 prints out before the destructing. That's again because the destructing happens at the end. So it's actually impossible for me to get something after the destructing in this system that I have here. So anyways, okay. If I try to run this function without any parameter, I get an error saying that there's too few arguments, right? I expected to have a parameter there so that the function could work. And that's true, because otherwise, what is going to be x? What is going to be couted if I try to call this without? Well, here's the thing. You can have this syntax here. Let me run it before I spiel. Okay, perfect. Now I know it's good. Okay. Because I usually use this as a class. I don't use it as a global function, but it works too. So here's the thing. You can create a default parameter by putting your parameter and then putting an equal to something here. And what this means is that if you call the function with the value something like 5, then it will take x to be 5. But if I call it without any parameter, it's going to just take the default value, which is 0. Let's make it not 0. Let's make it 1. So if I run this, because I did it twice, one time with the value here, and then because I gotta look this way. Here's the 5, and here's nothing. As you can see, we get a 5 and then nothing. So 5 and 0, and then here we have 5 and 1. The way I achieve that is by using this what is known as a default parameter. And so again, the way you do that is you list your parameter and then you set an equal to something. And what it does is basically says, okay, if the user or no, the coder passes you a parameter for the function, then you go ahead and use that for the value of x. But if they don't pass you anything, that's okay. We got you anyways because we got a default value that we'll just kind of use as a sort of a placeholder. Maybe they were lazy and they just use a default value. So this allows you to have a function that you can now call with a parameter or without a parameter. And you can do more than one. So I could do the same thing I have here with a second variable. And maybe I can cout x and then I can also cout y. Maybe a space between them and then the y and then still my end line. And so now in both of these cases, I'm going to get 5.1 and 5.2 because in neither one of them I actually passed a second parameter. But I can do that here. Let's make another foo, and this time let's pass two things. Let's pass a 9 and a 99. Oh, let's look at the function documentation for a second there. 9, and you can see there it says equal to 2, so that gives you a hint that that means that it's a default parameter, which is optional per se. You can think of it as an optional parameter. As you can see, in this case, I actually passed the 9 and 99. It actually put them as that. In these cases, I passed either 1 or nothing, and it filled it in. So it's very, very nice and convenient because then you can have a function that can do multiple things at once, depending on what you pass it. A lot of the functions that you use internally in C++ have this feature. Like getLine, for example, when you're not passing in their parameter, which is the delimiter, it just assumes the default is a line feed to stop reading. But if you pass a delimiter, then it uses that instead. So it's a very, 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 very commonly used thing. So it's a nice thing to mention. There is one catch though. And that is, suppose that you want to have some parameters that are required. So maybe like no matter what, I require the user to have a Z. And that Z is like mission critical. So like they have to have the Z in there. And if they don't, then I'm not going to let them get away with it because there's no default for it. Like they have to have that. Okay. If you're going to have parameters that are required to have, then those parameters cannot be at the end or cannot be after any default parameter. You have to have all the required parameters first and then any default ones. If I do this, I need at least one parameter. So that means that this one will no longer work. But in addition to that, none of these will work because of the issue there. So here, let me go ahead and put a 0 there. And now, if I run it like this, I get an error. I get default arguments missing for parameter 3, right? This thing will not work because it has a non-default parameter at the end of it. So the only way that you can mix and match required parameters versus like optional parameters per se, which are the default ones, is to put all the required ones first and then the optionals after. And then you're good to go. Okay, so now the 9, the 5, and the 0 are all my first parameter, which even though it's the first one, I'm putting it at the end. So that's why you see them here. So here's a 9, here's a 5, and here's a 0. And then these are the optional ones. So maybe so it looks cleaner. Maybe I switch these around. So Y, X, and Z. There we go. So now it actually kind of matches the ordering, so you see it better. So as you can see here, the 9 and the 5 and the 0 all went to the Z. The 99 went to the X, and then these just were the default ones for the rest. So that's the only catch about default parameters. They're great, but if you want to mix and match default and non-default, you got to put all your non-defaults first, and then your default ones. Otherwise, the thing will compile and give you errors and complain. So anyways, now that we've seen that, we can apply that knowledge to how we use in constructors. The way we can use it with a constructor is, in this case, suppose that we want to have a default set for the character. So if they create a level, and they can pass a character to kind of fill the world with, but they can also choose to like not pass anything and just have a default. So let's go ahead and make a default be the blank space. So we will always make blank space world for them. Here, just for a second, let's not make it so you can see it, and then we'll switch it back. But so basically, whenever they make a world, if they don't choose anything, in this case, they'll get an X, or they can do it by hand. So now, you know, I can do C for level 1, but level 2, oh yeah, I could do it like this, but it's kind of iffy. Oh no, it doesn't even let me. No, it doesn't even let me. Okay, you have to do it like this. Okay, I thought you could, but yeah. So you could either do it like this with the C, or you can do it without any parameters. I thought it would let me do it with the blank, but no, it's just like don't even put the parameters in. Just do it like that. So yeah. You can see we got C's and X's, but now we're gonna switch it over to blanks as default because that's kind of nicer. So default parameters are useful in combination with constructors to allow you to create objects as quickly as possible, and where some of the things you can choose to initialize automatically, or you can choose to initialize yourself. You can do the same thing with rank count. I could pass it in as a parameter that's optional. So let's go ahead and do that one too. So we can have an int r for round count, and we're gonna say that the default is gonna be 0, not 0, that's weird, 5 rounds. Okay, so now I could do something like this. Round count gets r, and by default we're gonna have 5 rounds in our game. That way I don't need to do this thing, but I'll still leave that. And there you go. Now, I am going to show you one other thing about this, but first there's a question. So like in the Battle Royale, the default could be space, but in the function was pushing the storm, you could pass S. Not quite, because when you're updating your grid to the storm, you're updating the grid. Here, constructors are running when you first create a grid. So when you first create the object, which has a grid in it, potentially. But once you've done that, that constructor never runs again. It only runs one time, and one time only. In that case, It's more of the set grid that you want to modify like that. And yes, you could have a default constructor in set grid, but then again, why are you calling it if you're just going to use the default? So I would not say that that quite applies to that scenario. But hey, if you figure out a way that it works for you, then go for it. So yes. Anyways, what was I going to say? Oh yeah, there is another way that we can do the round count. Another way that you can initialize member variables in C++, and this is just for your own information, I won't test you on this one, is you put a colon here, and then you can put the variable names that you want to initialize, and these are the class variable names or the member variable names, whatever you want to call them, so the ones that belong to level. You put it like that, and then it's almost like a function. You put parentheses, and you put what you want to set it to. And that basically does the same thing as this line of code does. But it's a little bit weird looking, okay? Very weird looking. You have this colon here, and then you're treating it as if it was a function when it's not. It's just an integer. But that's just the way it is. And it's actually a very popular way of defining. So when you get to TO2, they will probably be using this method when you take the class. But both ways work the same, basically. I don't know if there's a difference in speed from one method to the other one. And yet again, I'm sorry, I don't actually remember what this format of initialization is called versus this one. If there's like a special name, like aggregate initialization for the array thing. This might have a name, but I don't remember it, so it's okay. Like I said, I won't test you on that, but it's for your own benefit. In case you ever see this, you don't panic. You're like, what the heck is this? Why is there a colon in front of my constructor? Relax. And this, by the way, only for constructors, but relax. It's just another way. There's a lot of ways to do something, you know. It's like a synonym in English, you know. Yeah, so only for initializing constructor that you really use default parameters. That's the real good usage. Or I guess functions too, but you have to have a real good reason for it. So as time progresses and you code more, you may find sometimes that it must be something to avoid you from writing the same function twice. Which I can talk about with function overloading, but I probably won't get that to today. Anyways, okay, so now we finally created our grid and everything. So now why don't we create a square that is like empty in it, sort of like mimicking the storm idea. Stomach hurts. Okay. Yeah, let's just go ahead and do that next. So let me think for a second here. We want to, let's make a function that'll do kind of like the opposite of the game. In this case, it's going to render a square somewhere. Yeah. So it's gonna, let's say it's kind of like an explosion. It renders an explosion. It renders a little square, which just, you know, in a specific spot. So we'll call it explode, and we'll have one parameter, which is the radius of the explosion. And then, yeah, let's do that. Void explode int radius, which, yeah. Oh, by the way, you can write a constructor outside of the class the same way that you could do any other function. And we will do that so we get some space here. But there's a catch. When you do that, there's no type. So you actually just do level like that. It's weird, again, because constructors are weird. So don't feel too bad about that. Also, I think you gotta put that thing in there. Let's see if this will compile. Maybe get rid of it here. See if that compiles. It doesn't like the fact that I have the declarations in here. Probably because of the way I'm declaring variables. So I guess we'll leave it in there. I don't feel like debugging that. And yeah, we'll just let that be. So that I can actually get to the relevant stuff. Okay. Cool. All right. So let's go ahead and do our explode function and not worry about that. Okay. So otherwise we'll never get to this thing. It's like we're literally an hour in and we haven't done that. So yeah. Okay. So again, let me draw you what I'm trying to do here so it makes more sense. So what I want to do is, and this will compute the map too. This is a good thing to do. Before you start coding, figure out what you want to do. That way you don't do things unnecessarily. So we have our grid here, and what I'm saying is I want to pick a dot somewhere. So there you go. I just figured out that I need to actually pass more parameters in. I need to pass coordinates. So my explode thing needs three things actually. It needs a x and y and a radius. So yeah, I need to add some of the dimensions there. Very good point of why you should plan before you code. See? Okay. And from there, now we are going to make it a square, or we could try making it a radius, but let's just go with square first, because that's why in the assignment I told you use a square. It's just so much easier. What I need to do is I need to compute these four corners. Actually, well, technically I need to compute all dots around it so that I can render this correctly, right? So the next time that I render this, I don't want to render anything here. I want to render my own characters here, or I can add them in by hand myself. So how can I achieve that? Well, I know that there's a range of coordinates that I need to change. And those range of coordinates are sort of four directions. From the center, it's up, right, left, and down. So let's just look at one of them for now. Let's look at the left ones. Okay? If I algebra-wise that x and y represent my center, if I want to decide where this border is, then that border is going to be x plus that, which is this symbol here, okay? And that symbol there, L, is basically going to give me the coordinates here. So this coordinate here is, if this is x and y, and this distance is L, then this becomes x plus y, L. However, remember we flipped this like this. So in reality, my coordinates are more like yx. So this would become yl, and this is why, again, this is really good to do beforehand here in sort of in a piece of paper, because this is where you can detect these kind of errors. Like I would have totally got them backwards until I just thought about it as I was speaking it. So yeah, this becomes yx, and this actually becomes y plus l comma x. That's this spot right there. Okay? And because I know that that spot is that, what is the range of numbers that I need to change? The range of numbers that I need to change are going to be when basically let's call those numbers a's. Is basically when a is equal to x to a is equal to x. I put x again. I meant y. Y plus L. That's the range of numbers that I need to change to cover all of these coordinates here. Okay? So now let's try to do the right side. What is the right side going to be? All right, here's our center, and here's the edge of the circle. Okay. Oh, by the way, what is L? What is L in all of this? That's the radius, right? So I can replace the little L symbol with the word R. And there you go. Now you have one of the 4 directions, but we got to compute the 3 others. Now we're only going to compute 2, and then we'll just jump into code, because at that point we kind of figure out the pattern. But okay, so from there, again, this is our y-x, and we need to go all the way to the edge, which we figure out is just the radius. So if we want to compute this spot right here, then the second dimension is still x, but y here is not plus r, because that's this way. It's actually minus r. Like that. So basically, this point here can be represented as y minus r comma x. That's the coordinate point of that. Basic math. So now let's try to kind of mimic that. So let's call this b. What range of numbers would be included here? Well, that range of numbers would be from x, or sorry, not from x, from y minus r to y, okay? Which is kind of what we have here, but backwards. To b equals y, okay? So now let's combine them so that we can get the entire width of the square. Well, in that case, basically we need to go from y minus r to y plus r, right? That's going to be the range of numbers that go there. Will it go negative? Well, you are subtracting, but as long as the edge is within the grid, you're okay. But if it's not, that's okay too. So suppose that this is where the center is. Let's say the center is like outside. That's okay. You're just mathematically computing, theoretically, if there were negative grid dimensions, then you would print out in the negative area. But what you'll do is later on, you will check that you're not going out of bounds so that you stop rendering and you only render what's inside of the actual valuable area of the grid. But you can definitely, it's like when you have x and y coordinates, you can have negative ones. That's no problem. You just, if you're trying to actually draw something, you just ignore them and you ignore only the positive part. So technically, yes, you could go into the negative area, but you just don't actually print those out. What do you do here? Before you actually go ahead and actually draw this, you can cut off at 0. Okay? So, yeah, that's what we have to do. Now, what do we have to do for the up and down? Well, it's basically the same thing that we did here, but we just got to be careful about that. Because in this case, when we're going up, we're subtracting. When we're going down, we're adding. That's counterintuitive. At least to me it is. But that's the way it is because, again, our 0, 0 is at the top right here, okay? So if I have a dot here and I'm going down, I'm adding to the x value. If I'm going this way, I'm adding to the y value. If I go down, I am adding to the x value. If I'm going up, I'm subtracting from the x value. If I go this way, I'm subtracting. Yeah, I'm subtracting from the y value. Okay? So, how will this look like for that? Well, you know, if, again, we say y comma x is our center and we're going up, then we are saying that the top here is going to be now we're not touching x. Sorry, no, we're not touching y. We're touching x now, not y. So we say x minus the radius is going to give us that top edge there. And x plus the radius will give us the bottom edge. And so basically our range is that. From x minus r to x plus r. Okay? So it's backwards than this one. Just be aware of that. Okay? Don't be careful. Cool. So now that we got the math, it's much easier to actually put it in programming instead of trying to program and then get the math. So, first of all, what we notice is that we actually need 3 variables. We need an x and a y as well. So I'm going to put actually y first and then x. And then radius, which I'll just call r. Okay? So, before we do anything, baby steps. Let's just try to change the center itself. Nothing else. Okay, so how do we do that? Well, we got our grid in there, so we can just basically go ahead and look at YX. Is that safe? Absolutely not. It is definitely not safe. Let's put an X right at the center. So that means that what are we using to render? We don't want to use it. Let's just asterisks. Okay. And then let's call the function, otherwise we won't see it. So we can get rid of these ones now. We can also get rid of level 2. We don't need right now. And we are going to print the level 1 grid twice. But in between them, we're going to explode at spot 4, 4. And for now, the radius doesn't matter. So we'll do like 3. But again, it doesn't matter because we haven't implemented that. I forgot a semicolon somewhere. Here we go. So there's our grid and there's our explosion. That does not seem very correct. Not gonna lie to you, that does not seem right. 443. So I was expecting it to be here for. Oh, is it 443 or 434? 443. So yeah, I was expecting it to be there, but it got printed there. Oh, I know why. It's okay. It's just that I need to add a line feed to my print grid. Or actually, no, that would be not a nice thing to do. Let's just add it here, so I can see it. So it's actually it's probably good, but it's just that because the two times I printed it were like back to back. It sort of combined them into one, or it looks like one, but it's actually 2. So there we go. So now we got there. Okay, so I guess it's actually 5th spot because we're counting from 0. So technically 4, 4 is actually the 5th row and the 5th column. So yeah, don't forget about that counting from 0. So anyways, it is actually in the spot where I expected it to be. That's a good thing. So baby steps have been accomplished. Now let's take bigger steps, okay? Let's actually try to delete more than just the center. And again, by delete, I'm saying we're going to put an X because explosion X. So we need a loop. We need a loop through all of the spots that we need to remove, right? So let's just do a little loop here. And how many do we need to remove? Well, math time. If we're doing a square and we have to remove the radius in one direction and the radius in another direction, how much is that? Well, let's see. I'm trying to compute how many items in here do I have to potentially remove. Well, I know that this is a radius distance and this is radius distance, so that means that that is technically R, 2R to cover that. And then this way is also 2R. So how many squares is that? Multiply those two together. That gets you 4R squared. That seems correct. Yeah, okay. Because technically each of these is 1 R. And we have 4 of these. That's another way that you can think of it. This is an R, and then this is technically another R here, and you got 4 of them. So yeah, the math does not lie. Only we do to ourselves. So 4R squared. That's a good number to know, because now we could technically make this loop go 4R squared times. However, that's not really necessary because I think it's better. I'm thinking this as we go. It would be, because I haven't coded Battle Royale in a while, but it would be a good idea to do this as 2 loops. And each one, and one loop covers an entire row, and then it loops another column. So I think we'll go with that approach. We're gonna go with the y first. So y equals. Oh wait, I can't use that because I use those variables. No, there. Let's use I for now. I is less than. Is it like a Minesweep game? Yeah, per se. Let's do. How big do we want that? How big do we want to go from left to right? That's 2R. and then I++. Okay? So that would basically run the entire width of one row. So that. And then we will loop that for the number of rows there are, which is a 2R. I think that'll work. That'll work nicely. It should. So that would cover one row. In fact, let's just do that. Let's just do one row right now. Let's just render one row as exploded. Okay? And so that's going to be 2 times R. So what do we want to change here? Well, we're going to modify for now just the center row. So that's the row where the radius is at. So if you remember, the Y here and the X are flipped. So, you know, this is going as your Y, and then this is going as your X, okay? And so we need to do the row of Y that's equal to R, okay? So in this case, if you look at your grid here, X and Y, we want to keep this to be the same as it is. So this is the one that we're going to set static for now, because we haven't messed with that one yet. So we'll put that to R, because R is the row in the center. And then this one is going to be the one that changes with the loop. So that'll be our I. However, we don't just want to do this, because if we do this, here, let's try it. Let's make a mistake that's actually useful to learn. So let's not use an X for that for now so we can see it. Let's go ahead and put an at. Let's see what happens if we just do this, okay? It's going to put the errors, well, assuming I get the semicolons where I should. It's going to shift where I'm printing to the wrong area, okay? It actually did it vertically because I have the same Y. Okay, so yeah, so first of all, I did get the right number of spots, I believe, printed, because that would be 6 as it should be, because I got a radius of 3. In fact, I'm going to lower the radius down because otherwise we're going to, it's too small of a game where that's almost the entire half. So anyways, 4. Okay, so that kind of isn't the right dimension, although they flipped it actually. Why did it flip it? Did I actually get these wrong? X and Y, and then where did we have this? I guess I must have get them flipped. So here, let's flip them around again, because I want to do the horizontal one first. So interesting. Okay, but anyways, you can see that if things are on a different axis that you expect, just flip the parameters. So anyways, it rendered the right number for the radius, but it's offset, right? It's not where it should be, because it should be in the center. Now here, there's no perfect center because, you know, X is like right in the middle, so we're gonna have to shift it 1 plus or 1 minus. But the point is that it's offset. So now we gotta move it into the center. So we can't just use the I here when we're picking this. What we need to do is we need to do I plus the radius. And so now, obviously, it's not going to be perfect because, again, this is a 4, and then this is you know, you can't split 4 evenly when you have to have a center, you know. But other than that, you know, you have to choose 1 plus or minus. Or in this case, we're using integers, so we're just kind of chopping that off. But yeah, so now it's shifted to the right spot. Cool. Okay. We still have an error check. This is really dangerous because if our center was actually out of bounds, so if we switch this to be like let's do 0, 0 for the center, this might actually crash. Forgot to save, I guess. The center got switched, but that stayed in the same spot. Big mysterious question mark. Why didn't it move? Shoot. Let me see. For int I is equal to 0, I is less than 2 times the radius. Grid R. Oh. No, that should have moved it. I see. It was a mistake to choose R here. What I meant to do was choose X. Okay? Hello. There we go. Now we shifted it up in the right way. And furthermore, technically, we shifted it up, but it's not in the right centered. Because here, we should on the Y. Yes, now we should crash. But it didn't crash. Okay, but it still just put it on the edge there. So there we go. It moved it now to somewhat of the right spot. Okay, so anyways, for now, we will come back to fixing the potential error of going out of bounds. We will check that basically with just an if statement. But for now, we'll let it be as it is, and we'll put it back to here. But right now, it picked it in the right center, but it is rendering from the center to the right. That's not really what we want. We want it we want that to be the exact center where it renders. So we want to shift this down this way, because right now it's just going all the way to the bottom here. But it'll make more sense once we get the second dimension, then we can actually fix this up. So let's just go ahead and add that in now to avoid because otherwise it's kind of hard to keep track of this. Okay, perfect. Now let's just make sure we change the variable name so that we don't get confused. Or not us, but the computer get confused. And now we just go ahead and switch this to INJ. Actually, here, let's just put this in INJ for now. And I want to show you what would happen if you do this. If you do this, this thing is just going to completely flip all the way to like, just put it all the way there, okay? So this takes care of rendering the storm square, but on the top corner. So now we just got to, again, just shift it to the right spot, okay? And so how far do we want to shift it? We want to shift this the amount of the center. So Y and X. Okay, fingers crossed, this actually will put it in the right spot. I went too far. Okay, why did I go too far? Because it turns out that my math is wrong. When I shift this all the way here, so when I do the plus Y and plus X from that corner, yes, I'm pointing to the center, but I'm rendering from there. That's not really what I wanted to do. I wanted that to be the top left corner. So what I need to do is I need to figure out, in relation to my Y and X, which is the center of where I want to render the storm, where is this left corner at? So I got to figure out the math of how to get there. Well, we know this is the radius. So really, this point up here is going to be Y minus the radius and X minus the radius. And that'll get me the top left corner that I need. So because of that, I need to subtract the radius from both of these. So Y minus R and X minus R. And now it should shift it so it's centered here, approximately. Again, it's going to be off by 1. So there you go. It is off by 1 because technically it should go 1 here, but it's good on the verticals. It's just off by 1 on the horizontals. But that's okay. Actually, no, it's technically not. It's technically not at all, because 5 would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So yeah, this is where the center is technically. So it can't pick the perfect center because that would be right there in between that, you know. But it is close enough. If we want to move the center so that it looks more centered than this, then we can go to 5, 5, which would be the center of the grid, right? I think. Actually, no, it would be 4 by 5. Yeah. Grid Y. 5 by 4. That'll put it in the center of the actual picture. If you wanted it, just so we can visually see it. Nope. Other way around. 4 by 5. Let's try that one. Maybe that one will put it in the center. There we go. So there's the center. Okay, but that's because we're exploding that. Suppose we want to explode in the top left corner. So that one should hopefully crash. I actually want it to crash. So this time I think we'll actually get either a crash or it'll work, but it's technically going out of bounds, which is a very dangerous thing. Oh, well. Okay, so it went out of bounds, but it didn't crash. But let's actually see it if it worked. So we basically exploded the top left corner there. There we go. It crashed. So it actually crashes when it prints. Interesting, but it doesn't crash when I actually set it. Let's try it one more time just to make sure. Yeah. So interesting. So why is it crashing? Because of what you guys asked in the beginning. It's in the top left corner. So yes, okay. So how do we fix that? Well, the problem we're having right now is that when the top left corner is 0, 0, 0, we are doing basically 0 minus the radius, which is 2. So that's 0 minus 2, which is negative 2. And then if I happens to be 0, we're saying 0 plus 0 minus 2, negative 2. So we have a negative index in the array, which means that it's shifting the memory to 2 spots behind the first spot in the array, which may be valid memory, but it's out of bounds. So that's a bad thing, and that's why it may or may not crash. In this case, it is crashing. It's actually crashing, interestingly enough, when I print it, but not when I just set it. So how to avoid this? Easy. Go ahead and create some variables here called new x and new y. And ask your questions. If you see you have questions, so just type it in there. And so now we set those to 0, and then we can go ahead and basically take what is here that we know is good, and technically this is the y, so we'll put it here, and then take this, which is the x, and put it there. And then refer to them as this. And here, before we go any further, let's just make sure that works just fine by removing that explode and re-rendering it. Okay, so that's working fine. I did discover that I should add an end line here so that we can see the two differences. There we go. Okay, so now we're gonna add this back in. But now that we kind of separated, and I mean, this could all be done in one line of code, but we want to make it easier to read. What we're doing is we have a new x and new y. We can go ahead and check it. If new x is less than 0, then that means it's bad. It's out of bounds. So in that case, you can just set it to 0 so it doesn't go out of bounds. Similarly, you can do the same thing for y. This will fix some of the problems, but not all of them. Because, I mean, technically, we fixed negatives as being a potential issue. The other issue we could have is we go out of bounds on the positive side. And we can fix it in a similar way by comparing it not with 0, but with the max size of the grid, which is grid x and grid y. So we can also throw that in. We can add as an if statement here saying, and ideally, you could create a function that you would do these checks in so that you don't just throw random checks like this, and it's kind of bad practice, but whatever. We're kind of tight on time here. So in this case, we can say something like if new x is greater than grid x or equal to, technically because already at that point it's out of bounds, then that's technically out of bounds in positive side. In that case, the biggest grid value that you can have is going to be grid x minus 1. So you can throw that in. And then basically do the exact same thing for the other one. If new y is greater than or equal to grid y, then do new y gets grid y, which is basically the biggest you can do. Okay. The other thing you can do here, but I don't think it's a good idea, is just continue, because at that point you don't need to keep rendering. Actually, no, because you could go from negatives and so no, one more. So yeah, so this is probably the best way to do it. Quick and dirty, easy. Grid, we forgot a D. Segmentation fault. Dang it. All right, okay, let's see, where did we screw up? New x is less than 0. 0 is okay. New y is, oh, here. There's supposed to be a less than sign. Somehow it got put as a greater than sign. There we go. And so, voila, it worked. Yay. Technically, our 0 coordinate is right up here. Like, actually, it's this one, 0, 0. But now, we're okay because we render the stuff that's safe, but the outside area we don't render. We could even... like have a negative, a completely just offset circle that is like so just in the nether world here, and it will be okay. We'll just don't do anything. Okay, the same. They look the same because the explosion was like way off the screen. We could also have really positive numbers, and it still be okay. Ooh. Okay, so maybe we screw up the checking for the positive side. So if new x is greater than or equal to grid x, we want new x to be grid x minus 1. If new y is greater than or equal to grid y, we want new y equal to grid y. Oh, minus 1 here. Typo. See? So this brings up a good point. Always check your edge cases, all of them that you can figure out. Because as you can see, I naively thought, hey, we got everything good. It worked on the negatives. It probably will work in the positives, you know. It's good to go. Just turn it in and hope for the A. No. You're never done testing a program. Never, actually. And as you can see here, there was a bug. It's tiny. It was a little -1 that I forgot. And I wouldn't have noticed it unless I tested that special case with the positive end. Did I not save? Maybe I have more bugs now. I guess I do. I have even more bugs. Let's figure out where the extra bugs are. If new x is greater than or equal to grid x, new x gets grid x minus 1. If new y is greater than or equal to grid y, new y gets grid y minus 1. Oh, what is this? What is this doing here? This random at. I guess I was left from another time period. Yeah, that's causing the problem, because you can see how those could be out of bounds. So yeah, I don't know why that was. I was left there from like earlier when they was exam point. But yet again, that's a bug. It's still a bug that you left some development code in there that left, you know, found its way into production and broke your program. Get fired. Don't get fired. Oh no! Wait, no! What am I doing? What am I thinking? That's actually the line that you used to remove everything. I'm sorry. I thought that was something else. So wait, that we haven't really fixed the bug then. The bug has to be somewhere where we're going out of bounds in the positive side. So let's try to do the math on one of these values. 10. So if we have 10 for radius, or no, radius is 2. We start out with 10 plus 0 minus 2, which is 8. 8 is okay, technically. Actually, no, it's not okay already. But I would be detected as being the case. Not sure. This one we may actually run out of time before we fix with the really big numbers. I must be missing something in my logic here. Greater than or equal to. Greater than or equal to grid x, grid y. I can't see how it's possible to ever touch this. But here, let's actually I would open up a debugger to figure this out, but I'm gonna just go ahead and see out the new x and the new y, and hopefully by putting an inline here and flushing my output, I will be able to see what values actually break this, so that when it does break, I can I thought it was Python for a second there. I can see it. So this might be a good example to see where things break. So these are the numbers that are being printed for the coordinates. Ah, the stack smashing is actually happening. How many prints do I have? I have 1, 2, 3, 4. It's actually happening after I finish printing. So it's happening. Oh yeah, and it's not. Oh, I didn't even notice that. It's actually happening after the destructor is being called. So when the destructor gets called, that's when it's happening. Okay, so that actually kind of gives me an idea that I must have broken something bigger than just this little array. I could be overwriting potentially something in memory here. We have round count, we have our grid, we have the destructor. But why would it only happen if I do this? Because if I remove this one, it doesn't happen. I don't know. And I probably won't be able to figure it out immediately. We'll have to let it be as a big question and I can show you next time or something. But the error is unrelated. It's related and it's unrelated at the same time because it's only appearing when I'm going into positive numbers. But the error itself is actually not happening when I'm rendering the image. It's happening after the program ends essentially and the Destructor gets called. And for some reason the Destructor is, but what I'm guessing is after the Destructor is doing the stack smashing. I don't know, that's strange. So I don't know. But does anybody have any questions of what I've done so far? Today I've shown you how to use a constructor. I show you how to use arrays and structs. And I show you how to do default parameters and functions. What we didn't get to talk about was string streams, which it's just a random thing I want to throw in, which I can talk about tomorrow. And I also wanted to talk a little bit more about function overloading now that we've talked about default parameters and how that affects that situation as well. So yeah, we have stuff to do tomorrow now. But any questions, anything? Otherwise, I'll just try to figure this out for the next 5 minutes, and then if not, then that'll be the end of the stream. I wonder what is doing this. Can't think of anything. Well, hey, we share the same thought because I can't think of anything that could cause this problem. The values that I'm giving it are okay, right? 5, 6, 5, 6, and 3. Oh, I know what I can do. Let's try and first of all, let's actually space these two out. So I can see this better. So these are all valid. Oh wait, no, they're not. Oh no, they are because that's which one am I printing first? I'm printing a new Y first, and Y can go all the way to 10. So these are all valid. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 7. I think I suspect. What happens if I flip this? There we go. We fixed it. Not in the way that I would have wanted to fix it, but we fixed it. So let me tell you what I suspect was the issue here. I just want to see something first. Yeah, okay. I see it now. All right, so I'm glad I figured this out. So essentially, the error that we had was that when we were, at some point I flipped the X and the Y because I wanted to flip it sideways. But the problem is, I can do that fine, but I am still bounded by the dimensions here. And so while my dimensions here, the error checking was controlling not to go out of bounds based on these guys, as you notice here, I had the X and the Y flipped. And so I was trying to write out of bounds because of that. And that's pretty much what the error was. So, yeah. Essentially, that was the problem. Does that make sense to everybody as to why that was the issue? Basically, these were error checking all good, but then here I was printing it sideways, and so that was going out of bounds. That was the main problem. Now, are my dimensions and everything good here? Yeah, and if they're not, then I can just flip them and everything. But at least that fixed that issue. So if you run into that stack smashing issue, the reason that error is basically an out of bounds error most of the time. In your case, at least for the assignment. And the solution is you just have to check and see where you're actually going out of bounds. In my case, it was not obvious. I went ahead and COUted all of the dimensions, the coordinates that I was trying to input things to see if there was anything fishy there, like maybe a negative number or a number that was too big. But as you can see, 9 and 7 was the biggest that I could get because I have the range 8, 10. So that was okay. So that was one of those things where I'm like, okay, all the things that I'm printing are in the right dimensions. However, that one right there, it was giving you errors. So then I went ahead and looked at any sort of assignments that I was doing in the grid, and I saw that the X and the Y here were flipped. However, when I declared, I declared it as X and Y here. So obviously, not obviously, because otherwise I would notice, but because of that, I was writing it out of bounds. I was writing into spot 9, which in this dimension was only of size 8. And so that was crossing the errors. That right there was the big issue. So anyways, we have fixed that. And now we have a nice and little working, I guess you're right, kind of like a minesweeper per se. So in your assignment, you notice that you have to do the opposite. You have to actually do the storm rendering in. I didn't want to show you that because that would be giving away how to do it. But it's almost the exact same thing I did here. You just had to flip the math. Just flip the math. Think about it. The code that you're seeing here tells you how to render a square. In the other case, you want to render everything storm that is not in the square, right? So the square is the safe zone of the Battle Royale. So it's a little bit of a trick that you got to do. I believe the Battle Royale is due tonight. But either way, if not, it's good information to know. So it might be. I don't know. I thought it was due tonight. But yes. I can show you maybe tomorrow once it's to do what you do to flip this to achieve the Battle Royale storm. Okay? So that's it. So any other things? Otherwise, that is the end of the lecture. Well, hey, you did it early. That's very good. You can move on to assignment 12, which I'll talk about tomorrow, I suppose, a little bit. But you can start it. Yeah, you don't need me to talk about it at all. Actually, I mean, I could talk about it now if you want. Stretch. So, cool. I guess I'll modify this a little bit since we did not overloading technically, but default parameters. And then we shall save this for next time, string streams. So here's a snapshot for the YouTube thumbnail. All right. Okay. Oh, wait, it wasn't zoomed in. Dang it. Here we go. So the final exam is, oh, then that's going to show up too on the thumbnail. That's okay. The final exam is on Friday, just like the midterm, during the same times, 9 to 11. And it will be unlocked with web campus, the same, everything exactly the same. Just the day is different. It's July 10th, which is on Friday. So make sure you're there for that. 50% of your, 25% of your grade is counting on that. So we'll talk about that on, I believe Wednesday is the designated review day. So we will talk about the test then, and we'll review it as well. And then the test will be completed by then, hopefully. So I'm hoping to get the test done within the next 2 days. So, all right then. Well, thanks for hanging out, guys. I will see you all tomorrow at 9.